Today we're going to talk about building better worlds with Houdini and Unreal Engine 5. The industry is moving at unprecedented speed these days. The technology is advancing so rapidly. There's so much new tech that enables artists to build these incredible worlds with so much detail and so much rich content. And we're going to talk specifically about how Houdini and Unreal 5 can contribute to that content. So let's do so. I want to answer 4 questions. So we're going to talk about the what, why, where, and how. So the what. So what are better worlds exactly? Why automation and proceduralism in these better worlds can be a good way and a strong way to work. Where, if I want to integrate these procedural pipelines or procedural workflows into my pipeline, where do I put them if I already have an existing pipeline? And how do I implement those workflows? So to really discuss how to build these better worlds, we'll define and quantify, like, what do we mean by what? How can this understanding help us build these better worlds? So let me describe or the essence of 3 characteristics of what we think a better world might be. First one is finely crafted. The assets, the environment, it's polished, it's very high quality assets, very high quality look to it, no longer rough around the edges. We're really blurring the lines between cinematic and real time. On top of the individual assets that are so finely crafted, there's also the expansiveness of it. And that's just a direct result of all of the advancements that we've had in real time. And I'm not just talking about map size. We're talking about characteristics that are more details, closer to real life, more immersive than ever before. The third characteristic is lived in. We're talking about believable, more realistic, more style. Whether it's realistic or stylized, we want those worlds to not just be clean. We want to look like that creatures and people inhabit these worlds that give it that realistic, immersive feel. It's about the environment being part of the story. It's not just, you want the world to live and breathe. So those 3 characteristics that we observe, they're the ones that you see in the best games and the best real-time environments that you see. So how do we do that? And why should we use procedural workflows or automation to build these worlds, and why can they help? So in the next few slides, I'm going to present sort of a premise, some arguments about this. And as we know, we'll start with time is often your most precious resource. Time often spent on difficult, repetitive tasks, such as UVing, baking, optimizing, placing repeatable objects, checking to see if things are correct, validating your geometry or your assets that are going into the game. In a large world, any of these inefficiencies can be multiplied and compounded. Scalability is something to really plan ahead for with some of these tasks. And it's just impossible to do some of this stuff manually. It would take forever. And we all have time budgets and monetary budgets. So without automation, we might have to sacrifice things. And then what? Then we want to make our lives better. So procedural workflows can automate those difficult or repetitive tasks. They're scalable. It can handle what seems impossible workloads. And it can save time and reduce that crunch time. I'm sure all the environment artists in the room are very familiar with modular workflows. How many environment artists do we have? Okay, great. So you already know what modular workflows are like. And with modular workflows, it's already fun to experiment and play around with different results and so on. But the nice thing about proceduralism, if you're already in a modular workflow, you can take advantage of that because procedural systems fit naturally within those modular workflows. They can easily create large amounts of modular data or modular variations and automate some of this assembly of the modular systems with a set of rules to give you really great variable results. So needless to say, no matter how hard we try, there's always lots and lots of changes. It's changes that are outside of our control. You never really know whether it's an art director, whether it's player feedback, whether it's customer, client feedback. It could be a test screening for a feature film or a short film. You're always going to get feedback, and you're going to need to make changes. Well, procedural pipelines are designed to help mitigate or minimize the cost of these changes. Anything that's made at the base can propagate down so that to any step of the process and can accommodate some of those big, even very late changes, instead of having to go back and saying, can we get more time, or we might not be able to do that this time. So the good thing is that because of those things, it's not hard-coded. Instead, it's reproducible. It can be rerun with new parameters. And we're going to take a look at a lot of some of that stuff today, because all those downstream changes happen. It affects everything downstream. But the other thing that we need to think about when we're doing some of this procedural workflows is there is sort of an upfront planning cost. It can be hard to keep things organized, whether it's the pipeline or the tools or the assets involved in all of those pipelines. It's important for your own sanity and efficiency and consistency and reusability for future projects to keep organization in mind. And often a good amount of effort goes into this planning and organization. Certainly when you're working with Houdini and procedural systems, there's that upfront investment of kind of planning out what kind of tools you're going to need to use. But those tools can grow over time for sure. Procedural tools, they encapsulate all of these different workflows into nice, neat little modules. They're easier to clean, validate, keep consistent across the team. These modules, mean fewer errors. It's easier to document and hand over that work. And finally, the reusability for future project. It's good to keep in mind that you're going to save these tools for future work so that you're not going back and reinventing the wheel every time. So it's a good way to build up a bit of a tool library. Many studios across film, TV, and games maintain HDA libraries or tool libraries that have assets that they've built over time to solve problems that they have in their pipelines. So to recap, the benefits of proceduralism, it's time, it's the modularity, it's the costs of changes that we try to mitigate. It's project organization. But if I'm going to get these benefits, you might wonder, well, where do I do it? I have an established pipeline already. I want to avoid some risks. So where can I deploy this successfully? These would be great. These are great questions, of course, especially if you have we encounter that at side effects all the time. Studios that have these really established, well-built pipelines over years. Where am I going to put Houdini now? Where does that fit into my pipeline? So what we're going to do is we're going to take a look at some work from customers, from clients, from individual artists that have gone down that road of implementing Houdini into their pipeline. So I'm going to just play a little bit of this short film. Won't play the whole thing. This short was done by an artist named Jan, I hope I don't butcher his last name, Chubachi. So it really brings together many of the core ideas of this talk today. This is modeled entirely in Houdini. It's textured with substance in Houdini, and it's rendered in UE5. I also want to point out that this was not done by an industry veteran or a seasoned artist. This was a student graduation film that they completed over 9 months, and they learned Houdini on the fly. So why am I showing you this? Because I want to point out that small Houdini and UE5 together makes creating work like this possible for the smallest of teams. So we'll talk about the sand dunes first. So the sand dunes were all generated procedurally using Houdini's terrain tools. It's just Houdini's height fill tools. There's no solvers here. There's no sims. There's probably 6 different dune generators going on here. They were all blended together to kind of try and match the reference. And he looked at all this reference and picked a few and blended them together nicely. It's mainly based on just typical height field patterns with some whirly noise, some distortion, some erosion, sort of your typical terrain workflows. The fine details, we're using some of our masking tools to mask out certain areas and maybe up the resolution there. And then everything was split. The height fields were all split into tiles and then fed into Unreal Engine. The textures from Substance were used to drive some of the Unreal landscape-based materials. And it was all based on masks in Houdini and Houdini's terrain masking tools. The mountains, also entirely Houdini height fields. The layers and layers of masking and shaping to create these beautiful mountain ranges. Jan did a SIGGRAPH Asia talk on his workflow, so you could go in and see a lot more about what was done to do some of these landscapes. And he gives a nice detailed background, or breakdown. So here's a little bit of a comparison between the reference and the result. As you can see, the reference closely matches the result in Houdini. The main shapes, again, it was height field noise, it was some blur, some remapping, some clipping to get the plateauing and so on. Doing some carving, you can mask things out by feature. So you can define certain areas, or whether it's slope or so on, to do certain things to that. And then give sort of a unified erosion or slope or slump to it to get better results from that and kind of unify the whole thing. Originally, all the mountains were about 24 million polygons. Then they were down-res to 60,000 per mountain. So that way, inside of Unreal, he was able to take advantage of the ray trace shadows. The height field nodes, again, out of Houdini, generated these masks that were used for things like sediment, sand, water flow, normal maps. And then these textures could be fed into any materials you want. You can bring them, use them inside of Houdini for certain things. You can bring them into Unreal. In this case, he brought some of these maps into Substance to then further build his materials there using these as masks. Here's another beautiful use of a Houdini height field. Really nice sort of mountain terrain ranges, many different features here, slopes, ridges, valleys, crevices, and lots of details in there in a few different layers. This is the final result of that. This is a little bit of an older piece. This was done actually with an older version of Houdini and an older version of Unreal. But even then, I mean, the technology has only improved since Alexander made this piece. So you can see already we're getting some really beautiful results from that. And there's an 80-level article about this as well if you want to learn more about what happened in the building of this environment. But again, both pieces of software have much improved since then. Here's an example. It's a little bit more current. Again, we're starting with a Houdini height field here. So on the left, you see this is the Houdini network, that the green boxes or the network boxes there are defining different areas that are being masked out and saying, okay, these are the rules for where the trees are going to go. These are the rules of where the rocks are going to go. Maybe where water, bushes, shrubs, different things are going to go. And all of this is then encapsulated to what is called a Houdini HDA. How many people here are familiar with HDAs? Okay, so for those of you that are not familiar, basically that node on the right contains all of this stuff you see on the left. But what happens is when you build these workflows, you promote only the parameters that you want the artist to see. So in this case, that node on the right-hand side only has things to control the amount of trees, maybe some scaling, some scattering, maybe a seed to change how the scattering happens. And a lot of these HDAs can also be brought into Unreal using Houdini Engine, and those parameters that you have exposed are available to you inside of Houdini, or inside of Unreal, and we'll see a little bit about that in a second too. Everything, again, the result of that was all lit and rendered using UE5, and the terrain in this case is a nanite mesh instead of a landscape. Here's just another example. This is the artist here wanted to match this Vista photograph on the left from New Zealand and the right-hand side is the result of that. So one of the nice things about Houdini is that it could be as high level as you want and as low level as you want. You can build high level tools that are those HDAs that I described, and then you can get as low as you want. In fact, in this case, this artist built his own solvers for erosion using the tools inside of Houdini. So you can get as granular as you want. In fact, some of the tools that you already might use that ship with Houdini are just our own HDAs that we've built that encapsulate some of the solvers. If you've used any of our Pyro or RBD tools inside of SOPs, those are HDAs that have our DOP networks inside. And if any of you have used Side Effects Labs, a lot of those tools are those are HDAs that we have built to kind of give you a better experience. Cityscapes. So for the cityscape, we wanted it to have a sci-fi feel to it. Sort of went with a circuit breaker sort of a look, and there's some great tutorials from him on how to do a circuit board sort of layout inside of Houdini. And again, doing some smart kit bashing, you can build a building generator. So here's an example of a building generator generated these 6 variations, and then they're scattered based on some rules across the circuit board, and that's the city that you see in there in the little short. Again, to even expand out from that, you take all these little components and then you design something that says, I'm going to build out my city blocks with a set of rules. And those city block outs can be based on noise to determine how high the buildings are going to be on that subdivision or whatever it may be. A lot of this is inspired by reference. He wanted to get a paneled look, used a Labs lot subdivision node as part of Side Effects Labs that you can download. And just to do some basic extrusions and grouping. The city consists of a lot of regular buildings, some hero buildings. There's inner wall detail in there. Cable lines. We'll look at some examples of how you can do things like cables and wires. I'm sure we've seen lots of that out there, examples of that. But it has a bit of a hand-modeled look, but it's all procedural. Most of this is done with some of the slides you saw before, mapping out the city blocks and so on. And so here's just one final screenshot from that piece. Just another example from an artist out there that did, this is an aerial shot of Vancouver, used Houdini for the detailed terrain generation, for the architecture, and for the layout. And again, rendered in UE5. This one is one of my favorites. So it's not quite the realistic city that you might be thinking of or looking for. It's stylized. This is 100% Houdini in substance. So the idea here, so there's an HDA on the left-hand side. So it enables the artist to draw a curve. And as you draw that curve, it's, of course, mapping out the shape of your city or your city area. And then the primitive colors that you see on that curve. Let me back up and have it start again. Just so you can see it one more time. The primitive areas map out where there's going to be water, what type of buildings might be there. Is there a park? Are there sidewalks? And from that, it spawns, or you're able to say, okay, now I know what buildings to put there. And then you can add detail to that to say how high those buildings are going to be. And then you see there's sidewalks there. And you can put in logic that says, well, the sidewalk is flat and it's this long. I know I can put a car there because a car could park there. And again, it's the same thing with power lines and so on. And this certainly enables us to get lots and lots of variations. It also makes it easy to do things like have different resolutions of LODs and so on. So again, with that one tool, you're seeing 4 different variations that are is very easy to create using Houdini there. Another common use of Houdini as far as processing your geometry, if you have some geometry that you want to feed in, it doesn't have to even be generated in Houdini. If you want to take it from somewhere else and use Houdini to generate the LODs or generate collision geometry that then can be fed into Unreal. This is just some examples. There's really some great stuff out there. This is just concept art. You're not walking through, it's not moving, but there's a procedural system here that's able to just say, I want to come up with lots of different variations of building heights and building placement, and then you paint over it and you get a great way to get started on some concept art. another image for that. Building generation is a big thing that a really powerful feature that you can build tools with inside of Houdini. This is a procedural Japanese castle. This includes interiors to this. So again, you know, it's a little bit of planning in the front end, but then it'll help you to just very quickly generate lots of different building variations. So speaking of building variations now, I'm just going to run through some artwork just to give you an idea of this. Everything you're about to see was created by one person using sort of his own design building generation toolkit, starting with a townhouse and a residential high-rise. You know, this is sort of a typical house building that, you know, I don't know if it doesn't look that procedural, you know, it looks pretty good. Especially the one on the left, it could be seen as being handmade, but even though some houses have quite a bit of repetition to them, of course. Downtown buildings, spacious office buildings, you know, the one on the right, that was all done procedurally, and that certainly isn't as repetitive as you might think if you think of procedural building generation in your head. You're thinking all the windows are all the same all the way across, but that doesn't have to be that way. Here's some other interiors that I'll just kind of hop through a little bit, but all of these were created with a set of HDAs, a building generation toolkit inside of Houdini. The other thing too is, you know, it doesn't necessarily have to be realistic. Here's some really cool stuff, obviously some nice futuristic sci-fi things here. And it's a good jump off point for your next creation. So I'm going to take a quick little commercial break from buildings for a second and just talk about some hair and fur for a moment. I know that doesn't quite involve world building, but it is important. I want to make a note that it is easy, you know, with Unreal's strand-based hair rendering and Houdini's ability to take the pipeline all the way from the hair guides all the way to card-based and strand-based hair export. We're already seeing a lot of people using Houdini and UE5 together to generate hair. So this cute little guy here is a capybara. So if you saw the Houdini launch, there was a capybara in it, which is a real animal. This is some sort of, I don't know, a deer and a capybara together. I don't know how that happened. But again, back to grooming a little bit, you know, this is a character that probably had hair as a shell, and then this artist turned that into a groom, and then using some of our hair clumping tools was able to get some really nice results of clumped hair. Again, here is a good example of some grooming inside of Houdini. So far, we talked about cases, you know, use cases for using Houdini and building worlds as far as landscapes and city block design and all of that, and building generation and all that. But those aren't the only categories, those big expansive categories where Houdini can help. You know, you're going to have to interact, you know, as you're building these worlds, it's helpful to interact with some of the assets that are in the level or in your world already, because there's assets that depend on that. In the left video here, you see a snow mesh. So this is a tool that was built in Houdini. Let me back it up so it plays again. That big orange Houdini logo, that's what it looks like when you drop an HDA inside of Unreal. It takes a second to instantiate. But this is taking that surface, all of the geometry, even if it was generated inside of Unreal or brought in from somewhere else, it's fed to that Houdini HDA, and then that HDA is building that snow on top of those boulders. And the artist has controls, like I said, if those parameters are promoted inside of Unreal to control how much coverage of snow and so on that you have. So what's nice about that too is it's helpful when you're working with multiple people. Let's say there's somebody that's doing the block out of the environment, they're building some stairs. You can even block out where you want some of the terrain to come up and so on. And then that's fed into an HDA that then performs some erosion on it and then outputs the terrain into Unreal. And then from that, we can also use the snow tool to then build up snow on top of that any way we want. And should that artist down the line decide that he's going to change the layout of the stairs or the heights and so on of the terrain, then it's not really that much of a change for the person that maybe is adding in the snow. They might have to go back in and dial in some new parameters, but the workflow is fairly smooth. So here's an example of all that stuff kind of combined. There's a lot of other sort of typical, rule-based scattering that can be done with Houdini. I'm sure a lot of you may be familiar with some of that. It's something we've always done really well. But let's take it out of context. So on the left-hand side here, again, we're using a Houdini HDA to just do some typical, vegetation scattering onto some desert terrain. That's kind of straightforward. That's a flat surface. And you're just giving it some variation of scale and maybe a seed here and there. But on the right-hand side, what we're seeing now is you can take some of that height field information, whether it's the altitude or the slope, and determine, well, if it slopes this much, a tree's never going to grow there. So I don't want to put any trees here. But when I'm flatter and closer to the water, I'm going to have some greener vegetation. So these rules will help you build out these worlds efficiently and quickly based on sort of the terrain or the environment that it's in. Procedural tools can be used for modularizing things. I mentioned it before. You can take, sort of kit bashing, but take chunks of different things. In fact, our building generator works much that way, where you're taking some facades, and then you can decide which facade goes where, or scatter that, change some things around, some seeds, and get some nice results from that. This marketplace was generated that way. It has rules about where things should stack, where things should hang. And then you could take, once you make some of these variations, they can then be scattered throughout your environment as well. Get through some of these. These are just a few more examples of one tool being able to very quickly generate a lot of different variations. This is a great example. Here, that network on the side is the network that generates these rock formations that you see here. And they're all coming from basically a single shape at the top that just fleshes out the general silhouette of the object, and then all of the detail and all the other ridging and all that sort of thing comes from that network, and it can be encapsulated to expose only certain parameters. And those can all be combined along with that snow HDA to give you a nice little rocky environment like this. I think it's also important to know that Houdini also doesn't have to do the whole thing. There's lots of things that you can do as any part of the process, whether that's taking geometry, you sculpt it in ZBrush, but then maybe doing some UV work to it, or maybe generating LODs and so on. So it doesn't have to be only in Houdini. Houdini has a lot of benefits of just helping along. Again, think of the repeatable, annoying tasks that you won't want to have to keep doing. And it's not only organic and landscape type of objects that you can take advantage of some of Houdini's proceduralism with. With this gun here, it's a hard surface model that underwent a similar modeling procedure, but then from that, Simon wanted to build some sort of damage and destruction or sort of wear and tear onto this object. So, you take a mid-poly thing, you voxelize it and get a high poly version from that, and then the edge wear is added to that high poly version. And then those maps are written out and then assigned back on to the low poly version. You get the result that you see on the right-hand side. And that's all baked out, those maps. And the advantage here is there's no need for model subdivision. There's no sculpting required. All that damage can be done, like finding edges and curvature and so on, and putting some noise there, and you're generating those maps in a nice way. In this example, the artist wanted to kind of address that challenge of having a lot of objects. It's a small team. How am I going to build a massive amount of detailed meshes when there's not enough manpower? So using PDG, or how many people are familiar with PDG in here? Anybody? So PDG is our procedural dependency graph. And what it basically does, if anybody here has worked in visual effects, they'll get this a little bit, I think. But it's just the imagine of, like, okay, I have some destruction, and when this part of it is done, I can spawn some other tasks. And then when those are done, I can spawn these 5 tasks, and it keeps track of all of that for you, much like you would if you're doing a lot of simulation work and so on. So it focuses on, in this case, generating high polygon meshes, generating UVs, optimizing these meshes for nanite, and then generating some variations in some LODs. So just to talk a little bit more about it, it doesn't have to be about building super detailed things. Proceduralism can also just kind of get you kick-started, make some good silhouettes that you can paint on. Like here, these silhouettes were generated for these spaceships, and then they were painted over on top. Here's some prototyping that Mai did, that sort of doing some shader work, prototyping it in Houdini, because doing it in the material editor in Unreal would have been a little hard to work out some of the math. So he went ahead and did it here in Vex to figure out some of that, and then it was able to translate over into Unreal eventually. Again, these are just more examples. I won't keep hashing on it too much, but more examples of being able to kit bash things together, give it a set of rules, some variations, and build these tools to give artists, or artists on your team or yourself, the power to just change some parameters. And then using something like PDG, you're able to then distribute these parameters across our compute farm to get all those variations back. This is a great tool. I really like this one. So this one, this artist built a few different tools to then say, okay, I have this hallway. I want to do things like peel wallpaper. I want to maybe chip away at the drywall so that I can see through to the bricks. So these are all tools. In this case, you're seeing it inside of Houdini, but these could easily be brought in to Unreal. Same with spider webs. This is a great example of a tool that you could have where you place some points or the volume of where you need some spider webs to go, and your HDA will generate those spider webs for you. And here's sort of a time-lapse example of all of those tools we just saw sort of in practice. Things like placing trash bags, placing garbage along the road, dust, all of that stuff can be proceduralized, and it doesn't mean that it's repeatable or looks repeatable. Here's some more examples of a single artist doing things like building out some transit system, and then placing that in the world, and then building a kit that builds some building variations that then can be scattered throughout the environment. Here's some examples of, now those are a little bit repeatable, but they stick into a theme, as many sections of cities may do. They're placed in this environment in certain areas based on certain rules of the terrain. And then in this case, he also built a tool that has sort of using these ribbons, you can scatter these different structures in these panels and then place them in the background under those canopies in the back. Here, there's also L systems in use to generate some sort of basic trees that are then scattered in some of the empty spaces throughout the environment. And then some more details are added, like lighting and so on. So hero assets, the last thing on the asset side of things. You may assume that proceduralism really only pertains to something that's going to be repeatable, a city block, but not something that needs to be hero. But in this example here by Adrian Lambert, these are hero assets. This cathedral is hero. It didn't necessarily need to be handmade. And sure, a lot of parts of it are sculpted. The components of it are handmade, some of them, but they're used in a broader sense to build out this Gothic structure. And it talks about a lot of the themes I've talked about already. Many modules, there's lots of dependencies between components. Imagine if they came in and said, okay, I want to have a different amount of spires going around, or I don't want the cathedral dome to be as high, or I want to adjust the fence. Those could all be tools that you could build in easily to build that little gate tool around the top of the spire or something like that. So if a procedural, it really helps with sort of some damage control there. So here's just another example or a little fly through of it. Now let's look at the how. And we're going to talk a little bit about something you've probably all seen. It's the Matrix Awakens done by Epic, which is a great example of all of the 4 advantages of procedural workflows that we've talked about already. This entire city was reproduced 53 times during production. So if you watch, you should watch the two Matrix Awakens presentations that are out there. There's creating a world and generating a world. I mentioned organization and tool pipeline before. They have a very well-structured asset pipeline. It has a content library, Houdini city generator, and city spawning system. The content library is building modules. It generates building definition files. It feeds that Houdini city generator, and the generator processes the rules and builds out a point cloud that then is used in Unreal's open world system. The city is about 16 square kilometers, 6 square miles in size, 7,000 buildings, 27 different variations. In order to achieve this scale, modular workflows with procedural systems are pretty much necessary, I think. The tools are developed to create the module templates. You saw the curve island of the stylized, it's the same kind of thing. Color coding where certain city blocks will be, or determining the dimensions of that city block, and that's going to feed what kinds of buildings go into those areas. Again, 8 million module instances, 7,000 buildings. Here's a quick look at some of the setups that they used inside of that, including audio. I actually met the guy that built that setup last night. It was cool to talk to him about how he used Houdini to help with the audio placement. So I encourage you to watch some of these talks. Again, here's just some stats for the amount of work they had to generate 53 times, but look at all of the pedestrians, the buildings, the instances that were involved in generating that. And again, the dependency upon these things, if you think of, okay, we're starting with that city base, and what is that going to feed? That's going to feed down to traffic, to buildings, to the ground, and so on. Here's a quick look at in Engine, using things like blocking out, like, okay, this is the zone, this is a particular zone of the city. And that gets, once you decide that zone, then it determines what kind of buildings are going to go there, what kind of roads are going to go there. The building DNA is all figured out. What the footprints mean. What does that apply? Which library of buildings should I be pulling from? And then once you have that library, you can use an HDA to make some variations on that. And you can even feed these HDAs through PDG to kind of wedge out a bunch of different things automatically using a compute farm. Here's just a quick look of sort of the layout of the buildings and where they sit in that environment. So again, I'm going to, for the essence of time, skip through some of that. I encourage you guys to watch this, but it really does. I think it speaks for itself how many times this city was generated and how good it looks. I'll skip over that. You can use things like figuring out the corners of things, and that determines where, what facade goes there. Maybe there should be some sort of accessory or some sort of dressing there, or what kind of building goes there. We have things called volumetric overrides. So if you have one big building in this case, and you see the yellow wire frame, that's saying, okay, I want to put a scaffold there, or a fire escape, or maybe cut out a bit of the building and put a different sort of facade there. So you can go in by hand and modify some of the stuff that was generated procedurally. I think Kim Library mentioned in the opening session about the traffic system that they designed. Things like figuring out the intersections, where the flow of traffic could go. Are there traffic lights there? What kind of roads are they? Are they highways? Are they freeways? Are they back roads? Are they alleyways? And what kind of corner sidewalk goes in that location? And again, you can pack some of that scattering and saying, oh, I have this one community, and it fits in here, and that's what I'm going to put there. So it might be a set of buildings. And using our UV layout node, you're able to kind of separate out those areas and decide what goes there. Neon Giant. So this is a nice small team. They did a game called The Ascent. This is an example of using an HDA to decide where some cables go. And in fact, once you're in the engine, you can decide the width of the cable, how much it wraps, and it even has some physics attached to that. In this case, we're taking a pipe generator. I feel like when Houdini Engine came out, there was 1 million pipe generators out there. But this, the pipe fittings themselves were generated procedurally in Houdini, lots of variations. And then also The placing of them is a separate tool using a spline curve inside of Unreal, and then you can determine which fitting or which piece of the pipe goes there. Another example of using sort of a volume-based approach, so you kind of do some boxing of like, okay, this is where the building is going to be, both the positive and the negative areas, and then using sort of a JSON definition file, it then says, okay, from this I know that here I need to put this kind of a wall panel, and from here I might go to put a wall panel or a door, and then depending upon things like proximity or distance, you can put cables and things like that across and add variation to that. And of course, you know, if you're using Houdini, there's always destruction. I'm not going to go too much further into this one, but I want to mention that there's also some great sort of inspiration from Ghost Recon and from Far Cry of how to build out biome systems and tools around inside of Houdini on how you can place vegetation and so on and things like that. So I encourage you to check it out. A lot of that stuff can be found on our website. So Project Titan. Project Titan is something that we created over the last year or so. Simon Verstraat, this is some concept art, but Simon Verstraat, who was sort of our lead on that project. And it was meant for us to set out and say, okay, let's build something. Let's build something inside of Houdini for ourselves to understand what it's like to go through. We're very often helping others, but we often don't get to do it ourselves. So that's exactly what we did with Project Titan. It's a lot of Kitbash 3D assets were used in this project. But here's a quick example. There's a building generator tool, so you kind of map out the volumes of where the building facade should be, and then you have some controls over what goes there, whether there should be you know, balconies, air conditioning units, and so on. There's also a scaffolding tool. Again, you map out the volume where you want the scaffolds to be. You determine the height, the width, and so on, and then it can determine what kind of scaffold, and you can also control that yourself. Platforming tool. Again, you just quickly want to map out where your platforms need to be, and then the HDA itself determines where the intersections of sort of the bracings have to go. You can vary that somewhat, maybe add some custom bracings to that. So you'll see there's two platforms combined, and it figured out the bracings along the rims. And lastly, if you have some objects inside of your level and you want to drape some cloth or a tarp over that, that's also really easy to do with an HDA using some of our cloth simulation stuff. So it just drops down onto those objects. And again, here's just a little time lapse of that environment in Project Titan being built out. And lastly, I'll end with, these are just some other examples of beyond, you know, world building and so on. Here's some great examples of how you can use Houdini inside of Unreal to generate some cool effects and destruction and so on. So the takeaways, I'd say, we have a lot of new tutorials coming out always as much as we can. We're making them as fast as we can on how to take advantage of Houdini in real time. For you guys that want to go down this road, communication is really important. You know, the artists, tech artists and engineers all need to talk to one another because it's a team effort to make sure the tool does what you want it to do, is understandable and friendly enough for the artist to take advantage of it. Pre-plan. Don't be afraid to pre-plan so it doesn't become a chaotic mess later. And don't let tradition hold back innovation. You know, if you used to do things one way, it doesn't mean you can't try something new. You might get some really cool results from that. And again, we have lots of stuff out there to help you. Again, check out Side Effects Labs. The Side Effects Labs team is just amazing. It's under the guidance of my Al, who I can't thank enough for helping me with this presentation. We make lots of tools. We listen to the community of things that maybe they're used to doing easier in another package or something like that, and we want to try and make it easy for you, so we build tools around that. And we also like to experiment for ourselves to try and innovate as much as possible. And that's me, so thank you guys for coming.